Hello friends, welcome to C# Intermediate to Advanced tutorial. Now you are watching Subseries 6 thread synchronization using Monitor, also called as a critical section. So in this video we will see what is the need for thread synchronization. So what we will do here we will enter a number, say for example 10. Then we will click on this generate number and see how the sequence is generating. So here we will generate the number based on 4 threads, and all thread will run for the loop time specified here 10. So it performs a counting, and we want to experiment whether we are getting a number 40 towards the end. So all 4 threads share a same variable to do the incremental counting. So in the last video we learned about critical section, enter and exit. We also learned about a similar lock block which make use of enter and exit of critical section. So now let's proceed with the example. So as usual we include the namespace, diagnostics as well as threading. Then here if you see we declared 2 shared resources. One is seq max, so this one will tell how many number of time we want to run the loop. So this is not actually the sequence maximum number. This is a maximum time a thread will run to generate the sequence number. Then this one is the shared variable current count, and all thread will access this shared variable, and we will see the problem that we face when concurrent access on this variable is going on. So as already told in this input box, if we type 4, then the loop counter will be 4. That means 4 will be fed here, and 4 thread will run 4 times. That means when we are incrementing this, we want to see the end sequence number should be 16. So if you put 100 here, we want to see end sequence number as 400. So that's the experiment we are going to do here. When user clicks the generate button, this is the click event procedure that runs. And if you see from txt number.txt, we are initializing the sequence max, which is here. Then current count, we are initializing it to 0, which is already initialized, and anyhow we are initializing it for the second time. Then we are providing a short sleep for 10 millisecond. After that we are creating 4 thread instance. We usually use thread start. In all our previous examples we used the thread start delegate. Here we are using parameterized thread start. That means the task, here is the task we are feeding, right? This task can receive parameter. So this is a way you can create a thread, and the color of the thread can pass parameter to the thread task. Alright, here is the parameterized thread task, and we created a thread task, and task A function is not yet created. and there are 4 threads T1 to T4. So all uses the same task. Next, we start all 4 threads, and if you see here, we are passing the parameter. The parameter here is simply a string. So we are passing string as A, B, C, D. So once you click here, we start 4 thread. From this stage onwards, there will be 4 thread that is executing the task A. So here is the task A. If you see, task A receives a parameter, and that's the parameter we are passing here. And here is the parameterized thread start, and this parameterized thread start delegate will expect a function that takes object as a parameter. Alright, so we know that we are passing the string parameter, and if you see here, the incoming object, we are typecasting it as a string, then we are storing the ID. Then loop end equal to suq max plus 1. So that's how we are forming the loop end. Sequence max, if you see, we already passed the sequence max. So if you pass 4, sequence max will be 5. So if I pass 10 here, the loop end will be 11. That means we want to run the loop for 10 times. So that's why here we are adding a plus 1. And then we are forming a loop. Loop starts at index number 1 and goes with sequence max plus 1. That means if, for example, 10 is passed here, loop end will be 11. So in total, this will run for 10 times. Alright, here if you see, inside the loop, we are incrementing the current count. Then we are printing the incremented count. We pass the string so that you will get ABC, so which thread is incrementing it. After that, we are giving a short sleep for 50 milliseconds. So we know that this specific procedure will run by 4 threads. Here if you see, there are 4 threads we are starting, T1, T2, T3, T4, all executes the same task procedure, task A, and all share the same object. Because this is a member, right? Class member itself, we are running it as a threaded task. So member function task A is simply a member function on this form, and the specific member function is run by 4 separate threads. And since there are 4 threads, they all share same integer variable, or they all use read and write operation on this same current count member. Now here is a sample output. If you look at here, thread D 241, thread B taken and incremented it. So here if you see the current count, let's state this as V1, and V1 in this statement, if you see, it requires 3 operations. One is read, and another one is this increment. So we can call that as calculate, then write. So this means for write. So here we involve the calculation. That means we have to read, we need to increment, calculate, Then here is the assignment. That means we need to put back the value. So that is right. And if you see, all 4 threads are executing, and even though this is a single statement, when you translate this in microprocessor app code, there will be a separate instruction set for reading the content, for performing the calculation, then putting back the value in the register or the location where you read the value. So there will be 3 instruction set, and the context switch may happen anywhere, right? Also there is a print statement also that again reads the value and prints it. So now let's come back to this sample output. Thread D printed 241, and when it, so this is the console output when we are writing it, and thread B 242, and you can see the sequence number is going 41, 42, 43, 44, 45, and here is the problem started, right? So we like to see 46 here, but we see 47. One is skipped. It's because of this operations are not synchronized. So when all 4 operations, or at least this specific operation, performed in a single unit, then you won't see an issue like this. And if you see, here is one more issue. So the counting is gone, right? 246, then 249, 52, 50. Likewise, towards the end, there will be very little chance of getting the correct sequence number. Let's state that you are running it with a value of 50. That means 50 into 4. We like to see the output of 200. But since the shared resource is not synchronized, you will be seeing a value less than 200 most of this time, and in some rare cases you will be seeing a value somewhat higher than 200, like a 202 or 201. If it is a minimal value, you may be even seeing something like a 180, like that. And in very rare situation, you will be seeing 200. So when you are feeding the input, if you put 1 or 2, the likelihood of getting the correct sequence number towards the end will be high. But when you keep on increasing the number, definitely getting a correct sequence number becomes a rare scenario, because the shared variable is not thread sniff and it is not synchronized. Now let's go to the demo. So here is the example, and if you see, let's look at the form design and label 1. This is txt number, and this one is a cmd generate. So all this stuff we will learn in the next this one we will learn in this subseries. These operations we will learn in next coming subseries. All right. So we will go to view code, and as a first thing we will import the using statement for diagnostics as well as threading. Then as a class member, we will declare our shared variables. When user clicks the generate button, we want to create the sequence number by making use of 4 threads. So here start 4 thread to generate the sequence. So first we will place the code that will generate that will create 4 thread, As already explained, this time we are using parameterized thread. Task A not yet created. Here is for thread creation, and here is the thread start function. Previously we used a thread start with empty, with a void parameter or without any parameter. This time we are passing a string parameter. So you can use this same technique if you want to pass some data to your task. So it can be even a class instance, and you can pass that class instance to the task, and the task will bypass the class instance and make use of data to perform the task oriented operation. Alright, here we are simply passing the string to know which thread is invoking this shared variable. Now we will create the task. The task is task A, right? So here in task A, if you see, we are creating a thread ID. We are getting the thread ID as a parameter, and the ID here is ABC. Likewise, we pushed the string parameter to the task A. Then, as already explained in the PowerPoint slide, we are generating the sequence number by running a loop. Now, so debug write line, that means in the output window we are showing the count. So build all succeeded. Now we will run it. So first time we will give a very small number like 2, and we will click on the generate. So here itself, if you see, the sequence number generation is not going the way it was expected. So the count starting from 3, 1, 4, 2, then it ended with 7. So we can run multiple times. Sometime you may be getting the correct sequence number. So this time you are getting 8, but if you see, the sequence 3 is not there, but still you are getting 8. And when you run this with a high sequence number, let's state 100 means there are 4 threads which is running for 100 time, and all are accessing the same variable, and we want to see the sequence end as 400. Now, and I click generate here, it may take some time. Let's wait. And you can see all the threads run for 100 time. Thread 1, thread 2, thread 3, thread 4, let's say. And because of the sharing issue, and since the variable is not thread safe, if you see, the end result is 363. That means the count was gone wrong. Here if you see, thread A, C, D, all are pushing the counted value as a 362. That means here itself we missed a 3 count. And if you scroll up, you can see a lot of such a miscalculation, right? Well, because all threads are reading that value. So thread C read, when thread C read, the value was 346. D also read the same value. A also read the same value, and they are performing the calculation, and they are putting they are printing the value in the console output as a 346. So because of synchronization issue, we are seeing this. We can run this one more time, and this time the end result most probably will not be 400, but definitely you will not be seeing 363. There will be very little chance for that anyhow. So this time also we are seeing 362. Let me run this once again. 363, 362. This is the third sample run. This time 365. So definitely there is a synchronization issue. Now we will go for 50. We want to see number as a 200. So this time we are getting 182. So that means a count is lost because of the sharing issue or synchronization issue. So in the next video we will see how to perform synchronization when we do the calculation. That's all here in this video. Thank you for watching. Bye.